So the number of people are lesser today. So basically you can unmute yourself and you can speak. Okay. No issues on that. And then we can discuss. So guys, like let's start. And okay, so let's start. So first question from my side is basically, do you have any problem in logistic and linear? Did you implement those algorithms? Anyone? Rumi, you can you have on switched on the video portion. You can just video is not required. Okay, fine. So okay, so do let me know if you have any problem in linear logistic anything. So I'll be now today the topic is basically k-means clustering. So we'll start with k-means clustering, and the content portion is for today is basically understanding the k-means, and then we will understand the data for k-means, which is very real data, and we'll go on with the objective, the maths behind k-means clustering, like how do we calculate clusters, and understanding the optimal number of cluster, basically like how do you know that this number of cluster we have to take in this data set so that it would be optimal. Okay, so for that particular optimum number of cluster we use elbow method. We'll be explaining elbow method as well. Then we'll be fitting final model, and then we will do evaluation. So this is the entire content for today. So okay, first of all, just I just want to understand, like what concept or what theory do you have in knowledge about clustering? How do you define it? Do you have any idea? Anyone, like anyone can speak? No, do you have any idea of like what is clustering basically? Why do we do clustering? Okay, so what I'll do, I'll explain you. So I'll explain you in this way, like yeah, yeah, Arpita, correct. So basically, what we do, we basically try to make homogeneous groups within the data set, such that that particular homogeneous group is differentiated by other groups. How? Like if you see the India map, if you see India map, we have different clusters. How? We have different states, and the one state varies in a like larger scale than other state, right? But one state do not vary within them. So the variation within the group is minimal, like variation between the group is maximum. So we have studied this, right? We have studied, or you will be studying in your college. So this is the concept. When we try to cluster the data set or cluster any area, we try to minimize the variance within the group should be minimum, and it should be maximum between the group. Okay, so this is how clustering comes into role. So this is what clustering is basically. Okay, so the second portion is understanding the data for applying k-means clustering. So I have a data set. I'll be showing you in little while, and then we'll be moving. So the third portion is understanding the objective. So basically, for understanding the objective, we have a data set which gives it's an Australian basically retailer who has given us the data, and who says that can you just try they want to basically see the audience, like what type of audience we are selling the products to. Let's say if there are like middle class people, higher class people, lower class people, that kind of audience. So they want to see the audience, so that they can particularly give offers, and apply different strategies to that particular set of clusters. Okay, or groups or set of audience. So this is our objective. Basically, our objective is in very layman language. Is basically I've given I have a revenue column, and we have to divide revenue such that it should be optimally optimized. Okay, so that it clearly distinguish between the groups which we have divided, and then after optimally divide this cluster into cluster basically, then we have to somehow present this, and they would take some strategical measures. Clear? The objective is very clear. Okay, quick yes, no, understanding the objective is very important, guys. Clear? Okay, Mahendra. So fine. So you have understood the objective now. So now there would be the next step would be understand the optimal number of clusters. So we will be going to that a little later as well. So after that it would be elbow method, which I'll be explaining you for optimal number of clusters. Then we'll be fitting the model. Okay. So now the third we'll start with the like. How k-means clustering works basically. Okay, how k-means clustering work, what's the maths behind k-means clustering. So I'll be coming down, and I've taken very simple a data. Let's say I've taken a data set, and that consists of 1 2 3 7 8 9. Very simple to understand the maths, how basically it works. Okay, so that you can relate to a a larger data set, like what we'll be doing today, a revenue data set. Okay, so we have a data set, let's say D, and it has element 1 2 3 7 8 9. So at starting there are two splits, meaning if you from your domain, or if someone who is providing you the data is telling you we want 2 clusters, 3 clusters, 4 clusters, then it's fine, we will work accordingly. Okay, so sometimes it's possible, like if you are getting the data set from client, so the client itself says that we want 2 groups in this data set, please provide us the group and the visualization. Okay, but if that doesn't happen, like if you don't have any that expertise, or they haven't provided any information, so we would go to the second step. What is the second step? So we will from the data set, we will take two randomly points, select any two random points uh, from the data. Okay, and then let's say I've selected let's say I've selected 1 and 9. Okay, from the data set itself. Okay, so basically what I'm doing, I'm taking two random points from the data set D. Okay, and I've taken, you can take anything, I've taken 1 9, you can take 2 8 2 9 7 3, anything. Okay, now the second step of the clustering involves simply the point which I have taken here. So I'll compare this point to all my data set, and then put that data points into the cluster. So I'll compare, now one is closer to one, or other points. So one is closer to one, right? So you look this way. So I've taken 2 points, 1 and 9. So one is one is closer to 9, one is closer to 1, or one is closer to 9. It's closer to 1, right? So I'll put this into this cluster 1. Okay, again 2 is closer to 1, or 2 is closer to 9. So 2 is again closer to 1, right? So I'll put this 2 here. Again similarly, 3 is closer to 1, or 3 is closer to 9. So it's closer to 3, right? So I'll be putting this into this thing. Again I'll be coming to this point, 7. So 7 is closer to which point, 1 or 9? It's closer to 9, right? So I'll put this into this, and similarly for 8 and 9. So I've got two groups here. Okay, so but how do we know that this is the optimal number of groups, or this is the point that should lie in this group? So it's not confirmed yet. Again what I'll do now, I'll take the mean of this particular group which I've got from random points. So okay, so the mean of this particular cluster 1 is 2, and the mean of this cluster is basically 8. Right? Wrong? Anyone? Okay, fine. Thank you. So now I'll just iterate that similar process again in this group. So again, I'll just do one thing. So one is closer to 2 or 3. One is closer to 2 or 8. it's closer to 2. So similar thing I'll do for this. So I'll be getting this similarly, and again I'll just compare 7 with 8, 2 and 8, again 8 with 2 and 8, and 9 with 2 and 8. I'll be getting this exact similar cluster. So again I'll be getting mean of 8 and 2, if you see, right? So what I am doing here is basically, so I'm getting the mean repetitive. So I'm getting the mean, the above mean was 2 and 8, and again from the same cluster I got mean 2 and 8, because the cluster point didn't change. If it would have been changed, then the mean would have vary, and then we have to continue this process. But you see, the mean comes out to be same, right? So we will analyze and we will interpret that yes, this is the optimal cluster, this cluster 1. And so basically we have obtained cluster 1 and cluster 2. That is the maths behind clustering, k-means clustering. So this iterative process continues till we are getting same mean, you know getting my point, guys?
Hello.
So any doubts in this, any doubt in this math?
Um,
It's very simple. Basically it compares the each element with the points we are taking, and then divides the cluster, and that's it. And how do we know when we have to stop? By if we get the mean repetitive, then we know that we have to take that clusters, because it's the optimal one.
Sir, what we have the 5 in observations, like number 5, it is equidistant from both 9 and 1, right?
Sorry.
What if we have observation 5 in numbers what we took? Will it go to C1 or C2 as it is equidistant from 9 and 1?
Okay, so again, in this case, it would take any cluster, but again, when you that's the point of iterative. It would take in any cluster, but afterwards, when the mean will change, it would go to again, optimized cluster. Getting your point?
Okay. Yes, sir. Yes.
So that's why it's iterative now. So it would create iterativeness, and it would keep distinctness. So basically 5 would come in, let's say, any one cluster. So afterwards, when the points changes, so it would again optimized that way, because the mean is varying. And at point when mean will not vary, so we will consider that these two clusters are the optimal cluster.
Okay, so got it.
So anyone, any doubts in the maths? Basically, this is the simple maths. Basically, I've tried to understand, let you know. So this is how a k-means clustering works. Okay. So now, let's go into this is basically I've installed the libraries. So let me just call them. So I've called them, like I call them. So let's see the data set basically. Okay, so okay, one more thing. So since this data was provided by to us by client, and we have applied many algorithms in the same data set to fetch different insights. So one of the insights which we fetched was k-means through k-means to analyze the audience. Okay, so understanding the entire data set is not necessary. Okay, but I'll just give you a brief how the retail data set looks like. Okay, so guys, please mute yourself. When you're not speaking, mute yourself, because there's a background noise coming on. Okay, fine. So I'll just try to make you understand this data set. For this analysis, we are not using entire data set, because the entire data set is not basically required for our k-means clustering. So I'll be coming to the first variable. This is timestamp. Basically, when you buy anything, in Flipkart or Amazon or anything, any online retail, so when you are doing a purchase, exact that timestamp is captured. Okay, so this is basically that timestamp, basically 21/10/2017, 8:52. This is the time and the date you are purchasing anything. So this is the date, and this is the day name, this is the time, this is basically given in different columns. This is the user ID, This is IP address. Basically, if you are purchasing from anywhere, any laptops, so IP address is captured. Okay, so I'll be coming to product name. So let's say Kendrick is a product. Okay, and for the same, the product ID is given. Okay, so if you are purchasing any product, let's say from Flipkart, and for that particular product, we have a particular unique ID, which is product ID, which is very unique. Okay, so this is product ID, and this variable is actually important in terms of are you a first customer, or are you a like second customer or something. So like is first order. So basically like if I'm purchasing from let's say Amazon, so it's telling the Amazon that I'm purchasing the product for first time, like, or it was a continuous thing. So that kind of variable 0 and 1 is given. So a gender, basically a very important variable, user gender, basically male female is given, and what type of card or transaction we done through payment, basically. So the CC underscore bin trace, like basically Australian paying website. So this is the entire payment type through which we have made transaction, and whatever number of products we bought, whether it was one product, two product, and so on. uh, and then we'll be moving to basically order coupon. It's very comprehensive. Basically I have a coupon, so I applied it, so that coupon captured, they have captured. And if you see this EA15 is basically we get Swiggy in Swiggy as well. So that kind of coupon. So, and coming to geographic information, city, country, province, birthday, country code, and the final variable is revenue in AUD, okay, Australian dollars. So clear with the data set. It's very comprehensive. Basically it's a retail data set, because we do a very frequent purchase over retail. So we must be having similar kind of variables as well. So we will be using revenue column, because we want the client want to actually see the audience, analyze the audience, type of audience, basically. So we'll be using revenue. Okay, so revenue is something which if I'm buying a product, and what revenue is getting to Amazon or Flipkart or Australian retailer for this case. So that's the revenue portion given in AUD, Australian dollar. Okay, clear? Quickly, yes, no?
Yes, sir, it's clear.
Okay, fine. So I'll be also explicitly try to explain the codes. But yes, thank you, Gayatri. So but yes, like since many codes are repetitive, but yes, if you have any doubts, do let me know. Okay, so read.csv again for reading the data, and I've just did that. So now, since I told you like we are using only one variable, that is revenue, for this analysis. Again, I'm repeating. So the variable which the data set, the fashion retail data set, is basically we had multiple algorithms for this particular data set to analyze different objective. One was market basket, and there was many other things. So for now, I'm sticking to k-means clustering, and I'm just reading. I'm just using subset again, which I did yesterday as well, to fetch only those column which is required in our analysis. And I'm giving first argument is the data set. Second is basically select. I'm telling that select only 20th column. Okay, so I'll just run this command. So now, guys, one more question. So if we have 200 variables, let's say, in our data set, and I want to know, let's say, revenue.aud column was which number. So how do we know that? So for that, if you can just put this command, you can just put which, use column names function, give the data set, and put equals to the column name. So it would give the index of that particular column, so it would give 20. So you can just simply see that yes, 20th column we have to take it, and we can put this into subset column, subset function, and move further. Okay, fine. So again, coming to the let's say the variable which I put in D is revenue D. Class of D is data frame. Okay, so class is basically what? So basically I'm telling like I want to see like my data set is data frame, matrix, or vector or something. So it would give a class of data set. So again, I want to see the class of particular variable. So I use dollar sign. It would give me a numeric. So glimpse is something, it would give a little starting portion of the data set. So yeah, the data, these are the variable. The double is basically what it's saying, that it's in decimal. Okay, so these little functions are very important at times, so class and names and glimpse, so it's very important, and it's very basic functions you can remember. So okay, so again, why so again I'll just try to explain you. K-means clustering is something which is under unsupervised learning. We do not predict any outcome. Rather we try to cluster within the data, and we can use those cluster to give business knowledge, or we can use for that for those clusters for business purpose and so on. So I'll just simply fit the data set. So I have the data set. I just there was no cleaning needed in the data set for revenue column. All the revenue were given, so there was no mess basically. So what I'll do, I'll just fit the basic model. I'll use the k-means function. K-means function fits the k-means clustering algorithm in R. Okay, so the first argument it takes is basically the data set. Okay, so our data set in this case is D, right? Okay, so now the second argument it takes, it asks us like how many clusters do you want, how many splits do you want in a data set. So at start provided 4. Okay, let's give it 4. Okay, so now this is the problem. So this is the actual problem. We want to know how many clusters we should take. So it would we would go a little in detail now, but I'm just fitting taking it 4 now for now. Okay, so I'll just fit so it will give me something, and like so basically what this function did, it just classified the data set into 4 clusters. Okay, so now I'll just show you what are these clusters basically. Okay, so fine, so let me just, so yeah, so basically what I did, I just tried to fit a model which in which I said that please classify this data set, that means D, into 4 clusters. Okay, so we have now 4 clusters. So you guys have studied sampling, right? Sampling theory, sample survey. Have you gone like studied that? Did you like have this in this semester, or you have like in the coming semester? Anyone? Okay, so it would be very easy. Try to relate. Okay, so since I've divided a data set, let's say I've divided the data set, and it would give me 4 clusters. So again, so how many within sum of square would be there? There would be 4 within sum of square, right? So again, if I run this, so I'm getting 4 within sum of square. So if I put this 3, let's say I'm putting this 3, so it would give me what? It would give me 3 within sum of square. Getting a point? So it's very simple. We have studied this. So we are, if we are divided into clusters, so within sum of square what? Within sum of square is basically it would square each of the observation within that cluster, and it would give the outcome, right? So that is the thing. So what is the total within sum of square? It would add the entire within sum of square and give the total. So I'll take 4. I'll just run this. I'm getting 4 within sum of square. The total would be what? Total is getting this much, right? So what I'll do, I'll just I'll try to sum up this now. So guys, see, so I'm getting the exact same number, right? Through which basically this is the total within sum of square, is the sum of all this within sum of square. Okay, so why am I explaining this two terms? Because it's very important in further when I'll explain you how many number of optimum cluster we are classifying, then it would be in need there. So are you clear with the within sum of square and total sum of square? Within sum of square is nothing but within SS is basically square of the each observation within that cluster, and the total of all the four within sum of square is basically total sum of total within sum of square. Okay, got it everyone? Yes, no, quick yes, no. Okay, fine. So now, since I know, since first of all, I don't know in how many clusters I have to make it, but yes, I've fitted the basic model taking randomly. I've taken four in this case. You can take any number, but this number is not the point. The point is in like how many how we can drive that. Yes, this is the number. Okay, that is what we'll do now. So what I'll do, I'll just simply I'll just plot this above model. I'll see, basically it's different way of seeing the model. So I'll just plot this, and I'll be getting a plot. So actually my R is working very slow today, I don't know why. Okay, yeah. Okay, so sorry. Okay, fine. So if you see, this is nothing but whatever I did earlier. This is like a plot which I'm getting, and these are the points basically. This number of points are in cluster 1, this number of points are in cluster 2, these number of points are in cluster 3, and so on. Okay, there's nothing. So I wanted to show you this. And now coming to the most important portion, which is very important, which is calculating the optimum number of cluster. Okay, so now I'll just have you guys did a function, did you learn function in R, how to create a function in R and so on? Okay, fine. Fine. So what I'll do, I'm using that function concept here. Okay, why I'm doing here is because I don't know how many cluster to divide. Okay, so what I'll do here, the brief of this is basically I'll take clusters 1 to 20, and corresponding within sum of square, and I'll plot that particular both of these into a graph, and I'll see for which number of which cluster, for which number of cluster the within sum of square is optimized. Okay, so I'll explain you again. So let's create a function, a function which can take only one input, that is k. Okay, and what it will do, it will run entire model for that particular k. Okay, using a data set d. Okay, and it will store it will store the total cluster for that particular model. So let's say I'm running for one. Okay, I'm running for one. It will run for one, and then it will store total within sum of square. Again it will go to again for it will go to 2, and so on. It will continue to till 20, and it will store all the values corresponding totals within sum of square and give us the data frame. Okay, so I'll just run this function. So I'm running this function, and I'm using the sapply function. Okay, so I've stored all the within sum of square in this function. Okay, so for 1 to 20. Okay, so what I'll do, I'll just run this function, and it will give me, so it will give me all. Look, I've just headed this, so I'm getting the like sum of square of each k. But what I'll do now, I'll just I'll just put this particular number of clusters and WSS in one data frame, so that I can plot and see the number of optimal cluster. Okay, so I'll just do this. Okay, and head this. So look, what I'm getting is nothing but a data frame with a number of clusters. So see, earlier we had only the within sum of square. Okay, so what I did, I just corresponding to one, let's say k is equals to 1, within sum of square is equals to this, and so on. So I just why I did this, to just plot the graph, so that when I'm plotting any graph, so I have to convert the variables into a data frame, so that I can pass the arguments accordingly. Okay, so I did this. Now, so I've got the data frame which consists of two portion. One is a number of cluster, that varies from 1 to 20, and next is WSS that is within some of square. Okay, so I'll plot this. So now plotting this gives us a graph, and this is very important. Now I'll explain you the graph. So x-axis consists of clusters. So for the first cluster, that is 1, k equals to 1, gives the value of total sum of square equals to this value. Let's say any value is there, so it's not printed here. So again for 2, we are getting total sum of square, this some value, it would be line. So what it's doing, so whenever you see whenever cluster is increasing, the total sum of square is decreasing, right? So we need to the method we are using is elbow method. It's which is very comprehensive. So it's elbow method. So elbow means, wherever we are getting the flatness. Okay, like you see from this particular point, we are getting flat. We are getting, the vertical movement is decreasing largely from this particular point. So if you see vertical movement from cluster 1 to 2, it's huge. Coming 2 to 3, it's mediocre. Coming 3 to 4, it's becoming flatter. From this particular point, it's becoming flatter. So the turning point is basically this 2, right? This 2, the turning point. So we can take a number of cluster 3 or 4. It depends. Okay. So have you understood this graph? Okay, guys, I'll just explain you again, but it will the session will end. So please rejoin. Okay. Okay, so getting a point. So did you get how to analyze this, and how to take the number of like clusters? Anyone in doubt? Anyone in doubt? So did you understand how to interpret this graph?
Sir, what insights can be drawn between these two? The graph between these two terms.
Sorry.
What insights can be drawn between these, like graph between these two terms? Like we are calculating the optimal points, right? So what can be, what they are used for?
So basically, if we know the optimal number of clusters, so we'll put that into model. So that's the
Okay.
that's the reason. So since I earlier told you, so I don't know in how many number of clusters I have to plot. Let's say I'll
Yes.
go back. So what I'll do, I'll keep on trying this 1 2 3 4 5 6, but we are not sure of number of clusters to divide in, right?
Okay.
So this number of optimal cluster we are finding through a method called elbow method, which takes
Okay.
nothing, which takes nothing but we tell that we can take, let's say we are taking k value from 1 to 20. It will store all the for all the number of cluster, it will store the corresponding total sum of square. Okay. and
Okay.
uh, and we'll plot, and plotting that would give a visualization which is this. So we see that the number of clusters increasing, the error, the sum of square is decreasing, right? So
Yes.
the flatness which starts from is basically from the point 3 or 4. You see, the vertical movement from cluster 1 to 2 was larger, and it goes on. But you see, this is the point where the flatness starts, horizontal movement start, right?
Yes. Yes.
So if you see elbow method is basically what, it's very comprehensive. Elbow, if you see the movement of our hand, you see. So the movement of basically our hand is what it is. So here it is breaking, right? This point it's breaking. So this would be the
Yes.
optimal number of cluster, the number 3 or 4. So what I'm telling you, if you are confused about number of clusters, so it also depends on the domain. So basically from client side you will be getting, we want this number of clusters so that we have only 3 offers, and we don't want to give we want 3 clusters so that we can give 3 offers to each cluster, and so on. That kind of business strategy and business model can be made. That it's that is very one I said. But that retailers, Amazon, Flipkart use these strategies, basically divide these clusters. Using these clusters, you use market basket analysis as well. And if you are getting messages, why they are pitching you, because maybe you are those one of those person who is purchasing very less. So they try to give on messages, give on offers, so that you come and buy, purchase products from their particular online products, online retails. So that kind of strategy they use, basically from using this kind of algorithms. Getting a point?
Okay, sir. Yeah.
Yeah. So I've seen that the number of clusters can be 3, can be 4. So I've for in this case I've just taken 3, and I'll just come down, plotted. So okay. So yeah, so I've taken optimal number of cluster 3 here. Okay. And let's fit the model using optimum cluster. So I have fitted the model using 3. Okay. So again I'll show you model cluster and all. So you see, this is nothing but this is giving us the in which cluster the data point is lying, cluster 1, 2, 3. I'll show you in the data set as well by printing it. So this is the center. Basically center means nothing but the mean. Like in starting when I said you, we are taking the mean and then dividing, we are again taking the mean and then dividing. So this is that mean, basically. Okay. So this is that mean. We have, since we have 3 clusters here, so we will be getting 3 means. Okay. And coming to the next portion, I'll just try to put this in a data frame, and I'll show you. So yeah, so here it is. So you see, cluster somehow, clustering, k means clustering somehow, uh, put this particular value in cluster 1, and this particular higher value in cluster 3, and the lower value is in cluster 2. So somehow we have got the cluster, clusters of the particular revenue. So I'll show you in the Excel file. So let me just plot, and I'll show you. So somehow plotting is happening in very, like, taking its time. I don't know why. So yeah, so here it is. So it's nothing but 3 clusters happening here, and cluster 1 taking this number of points, cluster 2 taking this number of points, cluster 3 taking this number of points. Okay. So I'll just write this. Okay. So this is the basically end. So I'll just show you the Excel file. So okay. So you see, basically from the entire data set we got something. We got what? We got so we got 1, 2, 3. which means cluster 1, cluster 2, cluster 3, according to the values here. So somehow by using clustering we have got 3 clusters. So let me show you. So I've shown you the visualization and I've explained you something. Okay, so like I'll just explain you the present PPT we have prepared for that particular thing, to just give you a brief knowledge. So after plotting, you map the clusters according to the values. So we can get different insights. So we have to give names of that clusters. So we have got 3 cluster, 1 2 3. So you have to assign particular name that fits according to your analysis, that fits that particular cluster. So what I did, I just named the revenue, the revenue, basically the cluster with a lesser revenue. So I named it older people with a lower budget. Why I named this? According, it can vary, it can vary. So why I did this basically is basically, older people do not trust online things, right? It is very hard, to make a trust using older people. So older people we will buy offline. I'll just see the product and I'll just analyze the product. Like people they have like that kind of thought process. So this is the cluster 1. So cluster 2 I named young people with lower budget. So this is a bit of average. Basically these are I was referring this to a student. In student life we do not have that much budget, but also we purchase. Both happens at the same time. So I named it this. The third is basically middle aged people with higher budget. Why I named this is basically look for people who are working. Let's say you are doing masters now, and you are a student. So you are likely to buy many things, but since there is a constant of budget, so you are falling into this particular cluster. So now think you are you passed out in some you this master, you got a job and you are like earning some good handsome amount. And then the every you would be having a own budget and you can buy anything. So that kind of people lies here. So that kind of segregation I did on my knowledge. So this names and this analysis can totally vary in the data set, in the analysis whole entirely. So yeah, this is it. So for individual cluster I've shown like how many number of females, males, and these are like some missing value in the sex column. So don't go in this. But if you see female has always dominant. So like for example, females like online purchasing. So if you see older people in the cluster, older people they have higher number of purchases. In cluster 2, younger people with lower budget, they have higher. In every 3 cluster, like we have seen, females are somehow dominating. So this is the entire, and these are a few statistics, nothing but its number. Like what was the basically number number, like revenue number, basically 0.2 million approximately. And these are basically nothing but 87% buyer are females as compared to a different a male and a null. Null I'm not considering because it was not provided, but yes, male and in male and female there was 87%, and somehow here 83%, and somehow here 82% of buyer are females. So these kind of insights and client used and somehow. So yeah, this is it. So any doubts here till here, guys? So clustering is very is simplest of all algorithms. It's very comprehensive. Basically for people who are studying statistics is very important. Why? Because the maths portion is very much relatable. So understanding maths is very easy for clustering. The implications is very easy as well. So I'll just try to wrap up this. So what I'll do, I'll just try to I'll just try to explain you the process again. So this is nothing but again the maths which I've explained you what clustering does. You can also you- I've I've taken this data, a very simple data, and tried to do the maths. The same maths goes on for larger data. So understanding any maths or any algorithm, just take it simplest data and understand it. So that's what I did here. Okay, and install the libraries. These are very common portions. So starting from here, so basically why basically I don't know the number of optimum cluster here, so I took 4 and did the analysis. Okay, did calculated the within sum of square and total sum of square. And after this, like because I don't know the optimum number of clusters, so what I did, I just tried to make a function, and I passed k. Previously I passed 20, sorry, 4. So what I did here, I took k from 1 to 20. Okay, and I am trying to store all the total sum of square uh, for that particular k. Okay, which I showed you here as well, which I showed you as. So this is the function which I'm using here, which I'm creating here, to which will run for each k value and store the value. Okay, after this, I made a data frame of this particular wss and k. Okay, and then I'm plotting, and I'm simply analyzing using the plot, like what would be the minimum optimum number of clusters through this. Okay, and this is actually very important. This is the whole like heart of the algorithm, this number of clusters. So fitting any algorithm, let's say linear, let's say logistic, it's very a single function. So like we have seen, like in linear and logistic, we have to do multiple tasks like cleaning and visualization, but in clustering we didn't do that because it was not required. But the main portion was to calculate the optimum number of clusters. So we did this using an elbow method. There are also two more methods to do this. You can google it, you can try that. Okay, this is actually very important, and this is basically what this question can be asked in interview. So if you have applied k-means, so tell me the function of k-means first of all. So it's k-means in R, and how do you calculate how do you know that number of clusters should be this. So it can be calculated using elbow method. Okay, like we did. And again, the modeling portion remains same using simple function k-means. Okay, and these, like I explained you all this within sum of square and number of clusters, how mean are calculated, and so on. So it's very simplest and easy. So tell me, like, any doubts we can discuss. What output you are telling? Unmute yourself, Mahendra.
Yes, sir.
Yeah, what output you're telling?
K means the function.
Okay, so I'm running this,
You are
and
running it
what
to
output
basic
you're getting?
model, right? Yes. So I just want to know what will the output print like when we execute K means D of 4, I mean D comma 4. You are assigning it to a basic model and you are accessing the elements right within the basic model. So will it be a data frame?
Okay, so I'm not getting a question. We did like I just did this function basically. Okay, this function takes two arguments. Okay,
Okay.
first is the data frame, and the second
Yes.
is number of clusters you want to divide but that particular data set. So
Okay.
so 4 is basically what I'm telling to this function is divide the data set D into 4 clusters.
Okay.
And this is not very much clear with from any side. I'm taking this randomly. So
Yes.
deciding
Yes.
this value, we did the other thing, elbow method and graphs.
Yes. We calculated using elbow method. I
Yeah,
got it.
yeah. Anything else? So this was am I like satisfiable? Like is it your question?
No, no, that was not the question. I want to know what K means. The function prints exactly. Like you are assigning it to a basic model, right? So just could you please print like K means D comma 4 the function exactly without
Okay.
assigning it to a basic model.
So I printed. Yeah, I did print it, right. So you're telling this, right?
Yes, yes, exactly.
So this is nothing but it like since I've divided the into 4 groups, right? So we have 4 means here itself. Okay,
Okay.
Getting my point? And it's saying that the first observation is classified as third cluster. The second observation tells the second observation itself is in fourth cluster, and the third
Yes.
observation is in second cluster, fourth
Second cluster.
observation is third cluster, and so on. It prints all the
Okay.
entire data frame here.
Yes. Yes.
Okay. And also because the data set is actually big, so it says at the end, it says, like this number of thing was omitted, because it
Okay. Okay.
cannot print entire, because the data set is around 50,000. So and
Yes.
the somehow we are getting, like when we feed linear regression, logistic regression, so we can calculate individual stuffs as well, like coefficients, confidence interval, right? Model dollar,
Yes.
keeping model dollar. So here we can calculate the number of clusters and centers. Centers means basically means, which I showed you. Like if we are dividing into four
Okay.
clusters, so we will be having four means, right?
Yes.
total
Yes.
total sum of square and so on, within sum of square and so on, between sum of square, so on. So
Yes, sir.
size of each cluster you can calculate as well. It will give, okay, so I'll show you again this one. So if you put this particular thing, basic model, and put here and give dollar,
The
so
horizontal size.
size would give what? Size would give, in how many number of the strength of, each cluster. So the first cluster is of size 171, second is of
Yeah.
32,910, and so you can do a different analysis. So I'll be now giving you a homework. So if everyone clear with the process? The process remains same, the data sets varies, that's all. So maybe you are getting a larger data set, you have to dig more into the data set, maybe the client requirement, or maybe the objective changes, but the process remains same. How do we calculate k and so on? Okay. So now since I've defined in starting, like the little maths, try to focus on that. That would give you a very much brief, like how in a larger data set that is calculated. Okay. So like I have a homework. So there's a data set called iris data set in R. Have you heard of it?
Yes, sir. Yes, sir.
Iris does it. So try to explain, try, like the process which I've explained you, try in the entire Iris data set. Okay. Because once the process would be handy, then you would, it would be easy to, explore in different data sets as well. So Iris is very simple, then simple data set again. But first of all, you have to practice this thing, practice the procedure. So try using the IRIS dataset, and do the same process, and maybe you can mail the results to me at at stepupanalytics1 at the gmail.com. So I'll be going through that results as well. Okay.
Sure,
So
sir.
I'll be providing you the and this entire stuff. So I've written some like how what is the homework basically. So you go through this, and yes, this is it. So any doubts, anyone? You can like I'm muting, like I'm pausing the video now, so we can, so we